So at the top of the page, we are going to fill in those blanks. So 2 triangles are congruent. 2 triangles are congruent if and only if one can be mapped. Mapped is just like a fancy word for lining up. So if it can line up. Map onto the other by one or more rigid motions. Okay, that should be a review word to us, rigid motion. Get nod if you remember that word. That was our whole unit 3. What are my 3 types of rigid motion? Raise your hand if you know. 3 types of rigid motion transformation. Echo, you want to try?
Reflection.
Reflection is one.
Transition.
Close. Translation.
Rotation.
And rotation.
And you got dilation.
Dilation is actually not a rigid motion. Why? Anyone know why dilation is not?
It changes size.
Yeah, so rigid motion, remember, keeps the same shape and size, so that's why we're keeping them congruent, right? That's why we can use rigid motions to prove that one triangle is congruent to another if they map onto each other or line up onto each other. So today should be just a little bit of a review. This is cpctc, so remembering our corresponding parts. Anyone remember what this statement is called? That is the what statement? The congruent statement. And that's written right there, congruent statement. So using that, let's go ahead and list out, it wants us to list out the congruent sides and the congruent angles. So I would say angle T is congruent to, Katie, what angle? Angle T would be congruent to what angle? Good. Shelby, angle R would be congruent to? Angle X. And Corbin, angle Y would be congruent to? Good. So those are our 3 angles. What else do triangles have? 3 sides. So let's go ahead and list out our 3 sides. So I just start with the first 2 letters. So side TR. And then I pick a different color. Side TR would be congruent to Jacob. What side? Good. Then I'm going to do the last 2 letters. I always just kind of go in the same pattern. So RY would be congruent to what, Mia? XT. And we have 3 sides, right? Triangles have 3 sides, so now we're going to do the first letter and the last letter. So TY, Wyatt would be congruent to what?
DA.
Good. DA or AD, doesn't matter. Let's just get used to writing them in corresponding spots, but I know that would be referring to that same side. All right, go ahead and do that next one. I'll pause here. Go ahead and do that next one with your partner. This should be pretty simple. Okay, that was our easy part. Still a review and still pretty easy. These are examples done for you. So it is determining congruence. So seeing that these 2 figures are congruent if they map onto each other. So here, my pre-image is the one that's going to come first. So my pre-image is triangle ABC, so my top one. And it says that it was mapped onto this by a reflection. What would this be a reflection over? Someone raise your hand and tell me, please. Guess what?
The x-axis.
Good, that is a reflection over the x-axis. So we see that there, and those would line up, so we can say that they are congruent. So it's just another way to prove congruency. Here we have a translation. Does anyone remember how to read that coordinate rule? This is a nice little review for us. Corbin? Aubrey?
X plus 3 and y minus 5.
Good. Sorry, I should have specified a little bit more. So that tells me a direction, right? So x plus 3 would tell me what direction? Right 3.
Right.
Okay, I'm still Aubrey. And then
Down.
down 5. Good. So that tells me direction there. That's a translation. And then my last one is a rotation. With your partner, go ahead and talk to your partner. What direction was this rotated? Here's my pre-image ABC. What direction and how many degrees was that rotated? Go ahead and tell your partner real fast. Antoine.
Oh.
Aubrey.
It was 270. 270 degrees. Or 90. Negative
Okay,
90.
Ashley and Quenisha. What do you guys think? How many degrees and what direction?
Are you trying to be funny?
What do we think? You can also ask yourself, like, how many quadrants it moved. If it moved just one quadrant, that's how many degrees. Just a one turn is what? If I'm here and I turn here, how many degrees was that? 90. So you could have said 270 if you went a different direction, but let's say we went 90 degrees because I moved from this quadrant to that quadrant. So what direction would that be? What'd you say? Yeah, so what direction does negative mean? No, never mind. Negative means we're going the opposite direction. So this is how many? 90 degrees. Counterclockwise. So make sure you remember counterclockwise is going the opposite direction of a clock. Negative 90 would mean clockwise. You could have said 270 clockwise that way. So just a little refresher there for our rotations. So if you flip to the back, oh sorry, here's Mr. Bird's joke for today.
Why did Cinderella pick up the soccer team?
Because what?
Because she ran from the ball.
Whoa, how'd you know that?
Oh.
Yes, or have you heard that before?
No, she gave me the word ball and I was like, oh. She ran from
Anyway, come on, good job. I thought that was a good one. Okay, so up at the top of this page, these are still examples done for us. So this is another example done for you, and then we're going to do the one right underneath. So it's asking, how did I move ABC? Again, that's my first one, so that's my pre-image. How did I move that onto DEF with two transformations? So this is a composite. So first, they said, why is this not right? Sorry. Isn't there one up above it?
Yeah, there's one.
Okay, sorry, there we are. Okay, so this one is done for you. So it's asking ABC onto KJL. So they said first I reflected it over the y-axis. So you see that they actually drew that reflected over the the y-axis. And then it was translated down, and then this is vector form, right? So that would be right 4 and down 4. That's the vector form. So x comma y. So you guys are going to be doing that with this next one. So I'll actually start this one with you. So first thing we want to look at is the orientation, or the way it's facing. So looking at A, B, C, and D, E, F, are they facing the same direction? They're not, right? Hopefully we see that they are facing a different direction. So it cannot be a translation. So with your partner, go ahead and talk, is it a reflection that happened, or was it a rotation that happened? Just decide real fast with your partner.
Rotation, negative degrees, counterclockwise.
Okay, I hear a lot of mumbling of rotations. Who thinks rotation? Anyone thinks reflection? Okay, so it is going to be a rotation. We see that it is turned, so then we're deciding how many degrees did it turn here. So this is a rotation that we're going to graph. So please fill that in your blank. Now we have to decide how many degrees did it rotate. A good way to indicate that is looking at the quadrants, right? I was in this quadrant, and now I'm in that quadrant, so it's kind of just turned one spot. Devin?
90 degrees counterclockwise.
Very good. So this is a rotation 90 degrees counterclockwise that we need to actually graph first. So as a little reminder or a little refresher on how to graph rotations, we need to know what quadrant this is in. So this is the what quadrant? The what?
Negative.
The negative. Excellent. And we are moving into the
Positive, negative.
Put clockwise.
Oh, thank you. Counterclockwise. So I'm moving into the positive, negative. So do you guys remember what I have to do with my coordinate point when I do 90 degrees? You flip it, right? And then it needs to be positive, negative. So right now I'm at -2, -1. I'm going to flip that. So it's going to be a +1, -2. So please graph this one with me. So there's a, we'll call it A prime. You should be graphing this with me, please. So this is just a little review on our rotations, reflections, translation. Alright, let's do point B. So where is point B located right now?
-4.
-4. Well, I think it's -3. -1, 2, 3, and then
Oh, 5.
it says 4, but we only went 3 spots. -1, 2, 3, and then -1, 2, 3, 4, 5. So what number is going to come first if I flip it? 5. So it should be a +5 and a -3. So 1, 2, 3, 4, 5. -1, 2, 3. I'm going to plot that as B prime, and I'm going to go ahead and connect there. Can you already see that we're lining up in the same orientation? A and B correspond to D and E, so we are facing the right direction now. To make it a little bit easier, let's not rotate that last point. Let's just look at my other figure. I know F corresponds to C, right? F and C are corresponding. So if I count down from E, how many
3.
did I go? There we go. I went down 1, 2, 3 to get to my F, so I'm going to go down 1, 2, 3 to get to my C value. So I'm just kind of doing a little shortcut there. So there's my first image. My whole point is I'm trying to line it up now with my image. So decide with your partner, how am I moving this onto DEF? Okay, write a nice little rule, either in vector form or whatever. But we know it's a translation, right? So decide how I translated it to get onto my new figure. And I'm going to walk around and see what we got. I'm going to figure out how to get this one. Alright, so we knew this was a translation because it was just sliding from ABC onto DEF. So you could have just put a T if we were doing vector form. Remember, vector form has the little arrows on either side. So how many to the right did I move?
4.
4, so a +4, and then I went up 1, so I would put a +1. I saw some of you writing it in vector form. Make sure you have the arrows though. Some people have parentheses. And then I also saw people who wrote it in coordinate rule form, which was cool. So x + 4, y + 1. Either one of those were totally fine. So, yay, we remember translation. That's excellent.
I have a question, Ms. Ross.
Yeah.
What's the highest level of math like you like that?
Me?
Yeah.
Calculus 3.
Oh, was right. It was calculus.
How?
Calculus.
Calculus 3. Is it
Yeah,
hard?
yes. That's why I'm no longer a math major. That changed my mind real quick. Okay, number 4, you have 2 examples there that you're going to do with your partner. So I'll pause here and let you guys do it. It already kind of gave you a breakdown, so it already told us we're reflecting over the what? I'll do this one with you. We're going to reflect over the what here? The why. Why?
Because
Because you're just supposed to do.
it's on the other side.
Yes, we have. Good. Well, if we reflected it over the x, it would be pointing down, right? We want it now flipped over to the right.
Yeah.
So let's go ahead and do that. Remember how to reflect. We just count away. So 3. I'm going to go right 3.
1, 2, 3.
6. 1, 2, 3, 4, 5, 6. And that should line up over here. Okay, so we reflected over the y.
Excuse me, Miss Rowley.
Yes.
Do you have echo in class?
Yes.
This is Miss Floyd. Could he come up to the front office for just a minute, please? We won't keep him long.
Sure.
Thank you.
What?
Miss Ward.
They're
Miss
not going to
Floyd.
keep you long.
Oh, Miss Floyd? Oh, okay. I like her. She
Okay, that's reflecting over the y-axis, and then it says we're translating. Guys, we're still recording. Then we are translating where, Devin?
Sorry, man.
We've reflected it over the y-axis. Now we need to translate it where to line it up with DEF. Down. So let's figure out A should line up with what point?
D.
D. So let's count from A to D. So we went down 1, 2, 3, 4, 5, 6. So how would we write that in vector rule?
6.
Not 6. -6, right? We're going down. And did we move left or right? No. So what number do I need to put first? 0 and then a -6. Okay, and then we're finishing my congruent statement here. So triangle ABC would be Alondra. Where did it line up with?
Oh.
A, B, C would line up with? Thank you, Alondra. Alright, now I'm going to pause and let you guys finish the last one. And then I'll give you your review.
Oh my goodness.
Okay, so double check that you got the right rule. We went to the left 11, so it should have been in the X spot. And then A, B, C should be in the same spot as T,
It's an L.
G, H. Is it F?
Yes, that's very much an L.
But that's
Look,
not
come
even the
here,
alphabet.
Come here. Come here. It's an L.
B, F, G. Oh, it is an F. And
Yeah.
I.
This is why you only teach math, you know?
Oh, the alphabet is Okay. That's all for this lesson.